Yes, hi everyone. We'll wait for another 5 minutes and then we'll start.
Okay, sir.
Okay, so good evening everyone. My name is Oomang Bishnoi and I'm the senior course developer for Mechatronics. And I'm today we are doing a session on the automation in the JBM industry. And before we start, I would like to tell you about myself and the Elite Techno Group. So what I've done is I've done robotics and automation engineering from Vishwakarma Skill University, and I've worked in the JBM industry for 3 years. And currently, I'm working on developing a course for robotics and industrial automation for the Elite Techno Group. So what Elite Techno Group is doing is, this company, this is a startup, as you all know, and this company is helping engineering students to become industry ready, and we are helping any engineering student in any field to achieve what they want to, right? So today I'll be, doing this session like this. Due to some technical issue, my camera is not working. So we'll be taking up questions in between also. You can just unmute yourself and you can just, raise your question, or you can type in the chat box and we'll discuss after the session, right? So I hope now you can see my screen, right? Okay, cool. Okay, so our session today is on the automation in JBM Group, right? So what what automation is all about. If you have attended my few of the previous sessions, we have talked about different kind of robots that are used in the industry. We have studied about different kinds of robots that were used in the manufacturing of houses. Then we discussed about various applications. So I'll be giving you brief descriptions of all that in the coming slides, and we'll be discussing all these. Okay, so giving you an overview, we'll be giving you a brief about the JBM Group, what JBM Group is, and how we came to know about it, and what is it doing in the automation sector. Then we'll be introducing you to the automation, that what automation is, and how automation differs from how automatic differs from the autonomous. And then we'll be discussing about the automation in manufacturing, and then the hardware and the software that are used in the automation sector. And then we'll be doing a case study as is there a possibility of using 300 plus robots using a single PC. Okay, so coming to our first slide, JBM Group. Okay, so this JBM Group, it was established in 1986, and in 1986 the group signed a joint venture with Maruti Suzuki India Limited. As you all know, that company, this has Maruti and Suzuki had a collaboration, which they have cars like Swift and all these cars, right? For the manufacturing of sheet metal components, they had a joint venture. And JBM company is a tier 1 supplier of the automotive OEM industry. So I guess you all know what OEM is, right? You can just unmute yourself and tell me.
Original equipment manufacturer.
Right. Okay. So JBM has clients of Honda, Hero, and all these companies, and this company is the main manufacturer for body in white, chassis, suspension, die casting, exhaust system, and all these things. And this JBM company has 40 plus manufacturing plants all over the country. And these are few of the equipments that are used in the JBM for the automation. So do you know what this machine is? Okay, so these are hydraulic presses. These are used for components. So these are used to make components. So what it is done is, so these are called as dies. Okay, so you feed a sheet metal into the die, and then some kind of the die is designed like, let's say that you want to design a door. Okay, so die is made according to that, and a sheet metal is cut and feeded out of the machine the way that you want it to be, and some kind of manufacturing can be done on that according to your need. Okay, then second is, this is the MIG welding robot. So this particular robot is of FANUC, and MIG welding applications are done to join to different parts. And these are few of these techniques, automation techniques that are used in this industry. Okay, so second, coming to automation. Now, what is automation? Can anybody define me, like, what do you understand by automation? Anybody, like, what do you define? How do you define automation? Okay, so automation can be defined as a technology concerned with the application of mechanical, electronics, and computer-based system to operate. Okay, so automation is nothing like, machine is nothing but a bunch of sheet metal parts combined together to do different tasks according to the need of the human. Okay, so let's say that this robot without a human intervention is nothing but just a dumb metal sheet, right? Let's say that if you don't program a robot, according to your need. And let's say these are two parts, okay, and you want to join them using MIG welding, okay. So if we don't define a part, if we don't define a path for it, the machine will not do anything, right? Let's take for example automatic versus autonomous, okay. Autonomous, okay. So tell me this thing, is toaster, that bread toaster that you have at home, is this automatic or autonomous? Come on guys, I'll be needing your input. How do you define a toaster? Is it automatic or autonomous?
Automatic.
Okay, automatic. Any other inputs? Is it automatic or autonomous? Okay, I'll be in this. Okay, automatic. Right. So why is it automatic? If you're saying that it is automatic, why do you say that this toaster is automatic and not autonomous? Okay.
Because there is no decision power in this. Like
Right.
we cannot
Actually,
decide.
Yes, very good. Okay, so see the what automatic is. So automatic in toaster. Let's say that you put in your bread and then you start the toaster. You define you have a predefined limit of how much the heat it should have, and how much the bread should be toasted. And but the machine isn't making any decision. Let's say your bread is toasted and it gets burnt, okay, and it should come out that second, so toaster cannot make that decision. Whereas if that toaster were to be autonomous, okay, if that toaster were autonomous, it can define how how crunchy the bread can be according to the consumer need, and how fast that it has to take out the bread out of the toaster. Okay, so coming to another example, a traffic light. Is it automatic or autonomous? So traffic light, is it? Yes. What is it?
Sir, I think is automatic.
Okay. Any other inputs? Okay. So traffic light also is automatic and not autonomous, because traffic light, let's say this is a traffic light, okay, red, yellow, and green. Okay, red, yellow, and green. So it will just go on and on. Like let's say there's a 30-second time for a green light, and then it will go back to red light after that, and then 120-second, and again the process will repeat again and again, irrespective of the jam that is happening at the traffic light, or if there is a car or not. So the traffic light doesn't depend on that. But whereas if we had a machine vision, okay, so machine vision is a kind of a object that is that helps it to make, or if we define few of these parts with the current prescribed components, these can be made autonomous. Okay, so if we had a machine vision, it could have defined that how much traffic is there and how many cars are there, and that it has to turn green at that point or not. And so these are all the things that makes it autonomous. Now, what are the benefits of using automation? Now, what do you all think that how can automation help us? Like these robots are used in the manufacturing, okay, so these doesn't have any end effectors. And do you all know what end effectors are?
Sir, Idle time is reduced.
Sorry, what time is reduced?
Sir, no, non-machining time are reduced. Idle time is reduced.
Okay. No, I'm yeah, that is the benefits, but I'm asking about the end effector. Do you all know what end effectors are for a robot?
No, sir.
Yes, sir.
It is
Okay.
the last component with which we can perform several tasks. It's a welding,
Right.
paint job.
Right, right. Good, good, really good. So see, let's say I'll draw this. So these are the links that joins a robot, and these are the links which holds a robot into position, and these are the joints which help it to make some kind of movement to rotate in the environment. At the end is a and we place the end effector. Okay, so this can be of any type. This can be a gripper. This can be a MIG welding gun. This can be a spot welding gun. This can help us to reduce. There can be a machine vision mounted on it, or different kind of end effectors, which can help us to do different kind of tasks. So this doesn't have an end effector right now, but let's say they have some kind of operation to perform like the MIG welding, so they can place this MIG welding in the at the end and can perform those tasks. Okay, so now taking this robot into play, what are all the benefits of it? So one guy said that it can reduce the it can increase the productivity. What are other benefits of it? Okay, so I'll tell you. So let's say that a human is there. Yeah, that human is doing a MIG welding. Okay, he is doing manual MIG welding, and he is producing 50 parts in an hour. So that time can be increased by using automation up to 150 parts. Okay, so it will increase the labor output, right? And also the production output. Okay, it not only that, it will reduce the effect of low labor shortage. So let's say that some guy is sick today and he cannot come, but other guys are not that proficient in the MIG welding. Okay, so that can be reduced, since these robots, they doesn't have fatigue, they don't get ill, and they can work for hours and hours continuously. Okay, it improves the safety for the people. Like let's say there's a burning furnace, and robot has and you have to pick some kind of object from that. Okay, so robot can go in there without getting harmed, but a person cannot. Okay, it can burn. He or she can get burn injuries or something. What are the other benefits that you can see from the automation?
Sir, job failure are reduced.
Can you speak again?
Sir, આપણું sir workplace job failure are reduced.
Right, and not only that, labor costs are also reduced. See, talking about the benefits, we will see this on the from the point of the industry, right? Because these are implemented in the industry, and so the top management will always plan something or do something to prevent the current problems that are being faced in the industry, and they are going to do implement those things which will so that less human intervention is there, because wherever there is a less human intervention, there is more productivity. Okay, so let's say you must have heard that there's a company called Tesla. Okay, so Tesla is making EV vehicles, right? So if you have heard that the Tesla industry, they have at least 90% of the manufacturing plant has robots, right? And only the 10% are humans. Okay, and why do you think that it has implemented that? It is because of all these benefits, like improving the quality, reducing the labor cost, So these are all the things. So wherever there is less in human intervention, there is and there's more automation, like machine introduction. There is more productivity and less fatigue or less downtime. Okay. So coming to the automation in manufacturing. Okay, so we have few of the equipments that are used in the automation, which makes it autonomous. So first that we saw was the robots. Okay, so those robots that we saw, these are called as manipulators, and there are many kinds of robots. There are SCARA robots, there are AGVs, and many kinds of robots. So these robots have to be, these robots cannot, although these robots can work alone, but these robots are equipped with many kinds of, components. So one of them is sensors. So these are used for sensing the input parameters. So this particular, component that you can see is called as limit switch. Can you guess like what this limit switch can do? I'll give you a brief hint that this switch, as you can see, it goes up like this and down like this. Okay. So what do you think can be the use of this sensor? Okay. So let me tell you this. So let's say that this is some robot part. You guys must know that what is a fixture. Okay, so let's say there's a fixture and this product has to be fit on this. Okay, so like I'll put this part here, but how will I know that this part is in the right position? And the robot will only come and perform some kind of MIG welding or TIG welding, anything, and it will go back. It will not see that is this part in the right position or not. So limit switches are used for these kind of applications, so that they can detect that this part is in the right position and it does not move from its place. Okay. Then there are actuators we'll be studying so that it holds this part in the right position. Then there's PLC or SCADA. Okay, PLC, DCS, and SCADA. So what PLC does is, so let's say that this limit switch, as you saw. Okay, this limit switch produces an input. Okay, so this input cannot be directly detected by a robot. Okay, it has to be processed. It has to be signal conditioning has to be done so that it is in the readable form. So this PLC detects that input, and some kind of output is generated according to the programming. So PLC, you must know that these have NOs and NCs. And these are the ladder logic programs that are made in the control system. Okay, so let's say that this limit switch has to when we place that part in the fixture and that limit switch is activated. So some kind of actuation has to be done. And that is done using these kind of solenoid cylinders, which are there. And these solenoid cylinder, what they do is they clamp on the fixture so that part does not move, and it is holded in one place. Okay. Is there any is there any query? Just hold it up. Speak up. Should I proceed further?
Yes, sir. Actuator are be pneumatic or hydraulics?
See, actuator can be anything. It can be pneumatic cylinder, it can be hydraulic cylinder, it can be lamps, it can be it can be some kind of water like spray gun. So it can be anything like actuating element. So when we you must have studied in your computer lab that there is an input. So inputs are mouse, right? Then there are mouse, then there's CPU, then there's output as monitor or speaker. Okay, so same thing goes for industrial component. So in this, instead of sensor, there is mouse. So instead of mouse, there is sensor. Okay, instead of CPU, there's PLC, and instead of monitor, there's these kind of solenoid cylinders, right? So that is the thing. I hope it's clear now. Okay, so is there any other query? Right. So we'll be going further then. So first come the PLC, Programmable Logic Controller. So PLC is a solid-state computerized industrial computer that performs discrete or sequential logic in a factory environment. Okay, so what is I told you in the previous slide that we have a mouse, we have a CPU, we have a monitor, speaker, or these things. So why do we even need to use PLC? Can you guess something? That why do we need to use PLC?
Sir, converter of electrical signal to mechanical fast.
Oh, your voice is breaking. Can you speak again?
Sir, PLC is one type of converter electrical signal to mechanical types of motion.
But that can also be done on CPUs. Then why only PLC? Why not some other? Why not our regular computers? So I'll tell you. So see, PLC has a bunch of components. See, it is not just the single box. Okay, it has a CPU, it has IOs, it has power modules. So all these combined together forms a PLC, right? So PLCs are designed in such a way that they can withstand very harsh environment. So as you must have visited the industries, so industries are they have very huge temperature, they have very harsh environment. Parts collide with each other all the time, and then there's these equipments has to be strong enough so that they can withstand those thresholds. So PLCs are one such example, so they can be used like that. Okay, it can change it can change the electrical form into mechanical form, which is not entirely right, because it converts one form of signals to another, so that it can take the signals from the sensors, right? It will come to the CPU, right? So what language does CPU understand? You know that, right? Can anybody tell me?
Sir, language 01 code.
Right, 01 binary, which we call as, okay. So CPU understands that. So CPU translates it to that, and so according to the program. So PLC, as we know it, that it uses a ladder logic program. So can you tell me what is NO, as I'm telling you again and again, and what is NC?
Normally open, normally closed.
Right. You guys know, right? How do this work? Okay. So if you don't know, I'll tell you this. So let's say that there is NO. Okay. This is our logic, simple logic. I'm just explaining. Okay. This we will define as push button. Okay. So push button is like this. You press it, and some kind of actuation is done. Okay. So when we push this button, okay, let's just take a normal circuit. Okay, normal circuit. This will take a bulb. Okay, this is bulb. Okay, this is our normal switch. Consider this switch as NO. Okay, consider this bulb as this output. Okay, so when we press this push button, okay, it will turn into NC. So NC means normally closed. So when we close the switch, it becomes we say that this circuit is closed now. So the connection is entirely complete. Okay, so when this connection gets entirely completed, the bulb will glow, and this Y1, as we see the output, it will also glow, which is defined as bulb. Okay, so that is how the normal NONC works. Okay, but let's say that we also have an emergency button in industry. Can you tell me what emergency button is?
To stop any operation.
Right. It is simple as that. So I'll draw this like this, and then there's bulb. Okay. So this switch we will consider. I'll draw this here. Okay. So this is the push button. We will define it as P1. This is the emergency button, and this is the bulb. Okay. P1, E1, and B1. Okay. So this is normally open, as we talked about it. This is normally open. This is normally closed. Now we keep this emergency button as normally closed. So let's say that when this becomes normally closed, the bulb will glow. But let's say that this bulb heats up this bulbs get really heat up very bad, and we have to close it. Now, let's say our push button isn't working and push button isn't active. Now we will press this emergency button. So emergency button is always normally closed, and it will only be there to break the circuit. So when we press this, it becomes normally closed. Okay, so the circuit will become open, right? Can you understand all this? Is there any query? Please tell me.
For understanding.
Sorry?
Sir, continue understanding.
Okay, understanding. Good. Everybody is understanding, right? Okay. So this is how the basic, ladder logic works, right? We'll remove all this. Right. So second, so it was originally developed to replace mechanical relays, timers, counters, and other such devices. So these are the basic components of the PLCs. As you can see here, there's input. This is the push button. Then there's other things. These are all the input circuits. Then there's CPU to convert this signal into a readable form that can be understood by the computer. Then there's memory that we can feed this logic controllers. And then there's programming communication devices. So let's say that this push button has an input, some kind of input. So what this particular input has to do is, does it have to start a motor? Does it have to switch off the power supply? What does it have to do? So that is all defined by the programming communication devices. Then there's a power supply to power up all of the module. And then there's output, which can be in the form of motor, then the solenoid valves or anything. So these are all the basic components of the PLC, right? So then we have a basic ladder logic for basic gates. Okay. So first we have the AND gate. You guys must have studied that these basic gates in your colleges also. So we'll be doing this. JB and the logic. So let's say there's 0, 0 input. So if we consider this A and B as push buttons, okay, and this as, let's say this as motor, okay. So if we don't press anything, what do you think will be the output? Is it going to be 0 or 1? So one means that it is pressed or it is started. And 0 means that it hasn't started. Okay. So what do you think will be the output?
0.
Right. If we press 0 on push button 1, like if we don't press push button 1 and we press the B1, P1, P2, sorry. So what will be the output?
0.
Sorry?
0.
Good. 1, 0. What do you think will be the output for 1, 0? If we press the push button 1 and we don't press the push button 2?
0 only.
right? And if we
Zero.
press, and if we press both of them, we'll get a input 1, right? So that is how the basic gates work, right? Then we have the OR gate. So we'll be defining it again. Okay, so what do you think now? What do you think will be the output for the first one?
0 0 1 sir. 0 1 0
0,
1
1,
0
One.
no, 0.
One,
It,
one.
how can it be 1? Let's say that this becomes a NC. So the circuit will be completed. The Y will be active. So it will be 1, right?
1 1 1.
1
Right.
again 0 sir.
Now 1 0.
1 and 0 sir.
No, this third one, 1 0 is what will be the
1 1
right? This will also become 1 because it becomes
0.
empty. So 1 1 will also be 1,
One.
not 0, because they both will be active, and the circuit is completed from both sides, and the motor will work, right? This is the basic logic. If you are having any doubt, just clear it up.
So in Python, even the AND gate or OR gate, and here in electrical, it's mostly same. Why, sir?
See, sometimes it is different, sometimes it is same. So let's say that there's one there's one defining term in the PLC ladder logic, latching. You guys know what latching is? Okay, so I'll tell you. So let's say that push button is a simple, if we let's say this is the push button. Okay. This is Y1 and this is X1. So if we press this push button, this becomes NC and this motor gets started. But as soon as we leave the push button, this becomes NO and the motor stops. Now, to keep it active, we define a latching. Okay, so latching is like this, and this is Y1. So what latching does is, so whenever we press the push button, the motor will start and this becomes NC. So as soon as we leave the push button, this becomes NO and this circuit is still closed and the motor is still on. So that is how latching is done. So I might not be that fluent in Python, but this is how the latching works for these PLCs. Okay, I hope this clears your doubt.
Yes, sir. Clear.
Yes, sir.
Okay, good. Now we have two more gates. We'll be defining that. So then we have the NOR gate. Now, what do you think will be the output for this? 0 0. We have what will be the output? See, the output is going to be 1 because these are NCs, and the circuit is already completed, so the motor will be active, right? So Y will be 1. So logic is Y, right? You understand that? So 0 0. If we don't press any button, it is going to be 1. If we press this button, this becomes NO. Okay. So what is going to be the output for this? 0 1. What will be the output for this?
0.
Right. It is going to be 0 because the circuit is broken. The circuit breaks here. Okay. If we press 1 0, this becomes NO and this is still NC. So the circuit is 0. Now, if we press both of the button, it is still going to be 0. So that is how this works. Then we have the last gate, which is the so this is the NAND gate. Okay. So what is going to be for this thing? 0 0. So for 0 0, I'll tell you these are NCs, and the circuit is completed. This is going to be 1. for 0, 1. Now tell me this: if the B becomes NC, NO, what is going to be the output? Is it going to be 1 or is it going to be 0? Come on, guys, I need your input.
Sir, repeat question.
See, if we press this button, okay, this is NC currently, and this becomes NO, right? So what is going to be the output? Is it going to be 0 or is it going to be 1?
0, sir. 0.
No, this is going to be 1. I'll tell you why. Okay. So since it becomes NO, but the current is flowing from this side, right? So this is NC only, and the motor is going to be started, right? So this is 1. Just clear any doubt if there's any. Are you understanding this?
Yes, sir.
Okay. So what if I press this? This becomes NO now. What is going to be the output? This is NC only.
One.
Right. This is going to be 1. Now, if you press both of these buttons, it is going to be 0, since these both becomes NO and the motor is not going to start. So this is the basic idea for the logic gates, that is used in the PLC programming. Now there are more to the programming, but we are going to be covering those in our later bootcamp. Okay. So coming to the next part, we have the DCS. So DCS is the distributed control system, which is a specially designed control system used to control complex, large, and geographically distributed application and industrial processes. Now, think of this thing that if we have PLC, why do we even need DCS? Why do we even need DCS if we have PLC? See, DCS is just a control system. Like let's say you can I have a single desktop in a single room, so and bunch of components with me, so I can control all of the industry with those components. But if we have PLC, which is also used to control those components, so why do we need to use DCS? See, we use DCS because these are used to see, PLCs have all the advantages in the world because we are using it in the industry and for the industrial application. But there's a downside to it, which is it has a limited number of IOs. So IOs are the inputs and output module, which are used in the PLC. So for the DCS, we have various communication modules. Then we have Profibus, which not only has 126. It can be connected to 126 devices, but it can be increased more, right? So those are the use of DCS, and that is why DCS is used. So let's say that we'll be studying the case study also, that how can we control those 300 robots. So DCS is one of these things that makes it happen. Okay, so let's say that a robot has a manipulator, it has a control system, it has a teaching pendant. So those teaching pendants can be brought to one place using those DCS, so that it can be so if there's a fault occurring. Hello, is there any doubt?
इधर से चलते हैं ना.
Can you turn off your mic, please? Yeah, thank you. So let's say that if there's a fault occurring in the industry and you cannot go to the line, and there's a harsh environment and it is not feasible for a human to work in, so it can be controlled from using DCS from a single room. Okay, so that is the whole idea of DCS. Okay, is there any doubt?
No, sir.
Okay, cool.
Hello, sir.
Yes, please.
Sir, Arduino sensor is working in industries. So what is function of?
See, I've been asked this question many times, But see, Arduino is just to give you an idea of how the basic sensors or basic actuators work. Okay, so these have limited number of applications. These are used to give you an idea as to how these things work. But to implement in industry, there are these are done on a large scale. Okay, so these sensors are we have some more we have some more sensors. Let's say that we use proximity sensor. Okay, so proximity sensor is also used in Arduino as well as in industry. But for the Arduino, they have a limited number of application and they have a limited number of area that can be covered using those sensors. But in the industries, they have some extended version of it, and that is how these things are not used in the industry. Then Arduino has another factor, as I was discussing, for the PLC. So PLC can withstand those harsh environments that are used in the that are there in the industry. So Arduino cannot withstand that. Okay. Then in place of Arduino, we use some other components that will be defining in the later bootcamps. But this is the basic idea for Arduino. I hope this clears your question.
Yes, sir.
Okay, good. So these distributed controllers are connected to both field devices and operating PCs through high-speed communication networks. So as we can see here, so let's say consider these as actuators. Then these are some rack modules which are there for the communication, and these different, let's say these are two different plants, but they are in a single industry. Okay, so these have a basic controller in a room which are known as the operator workstation, and these three computers can control all of these actuators from a single room. So that is the basic idea for DCS. Okay. Now coming to SCADA. Now we have been having these things that PLC, DCS, SCADA. So I'll be defining those all. So let me complete this SCADA first. So it stands for the supervisory control and data acquisition software. So defining these two terms differently, what do you think can be the work of SCADA? Okay, what do you think is the supervisory control?
That's monitoring the every control.
Yeah, let's say that we have seen that there are supervisors in the industry. Okay, so there is a single line. Let's say these are robotic cell. Okay, these are 4 robotic cell. So they have a supervisor on the. So workers are working on the robotic cell individually, but there is a single supervisor for all of this line. Okay, so supervisor supervises the whole line and make sure that the line is working properly and there is no fault occurring in that. Then there's data acquisition. So data acquisition is there to acquire the data that is generated from these robotic cells. So let's say that there are faults. Okay, so there might be. So do you all know what HMI is? Human machine interface. Okay, so human machine interface, this is this is a basic device. This is kind of a touch screen. Okay, so you have some parameter. You can draw. You can design HMI any according to your need. So let's say that this particular HMI shows you the fault that are occurring. Okay, and it shows you the production, right? So this acquisition, the data acquisition. So this data acquisition can be done from the HMI that these kind of faults were occurring on this robotic cell. Then this was the production on this robotic cell. Then this was the fault on this cell. So that is the data acquisition, right? So SCADA is basically supervisory. It is a system that enables an electric utility to monitor, coordinate, control, and operate distribution components and devices in a real-time mode from remote location with acquisition of data for analysis and planning from one central location. Okay, so this is the whole view of the plant that can be drawn using SCADA. So let's say that I am the manager of the plant or I am the owner of the plant, and I want to see that what is the production on this particular robotic cell. So I can see it from my computer using SCADA. Okay, so this SCADA software can be designed, and it will be shown on my computer that this particular robot had this production, and let's say that the production was supposed to be 100, but it was 95. Then I can see what were the faults occurring on the robotic cell, due to which five parts were lost, and that is how the basic SCADA system works. So is there any doubt in it?
So can I see the working principle, sir? Like how does it work? The concept
Yeah,
is quite yeah. Yes, sir.
See, the SCADA basically is a human-machine interface. Okay, so human-machine interface, it shows you the animation. Okay, so as you can see that this tank has 30 liter in it. So it will show you this thing that the water is at this level now, and it will go beyond this, and then the sensor will be active, and these are the sensor. These are all programmed, and PLC, DCS, SCADA can work together, and we can draw software on something, and then human machine interface can be seen according to that and designed according to that, and that is how the basic technicality works. Now let's say you were saying that how can I see the robot functioning of the robot. So let's say that this is a manipulator, and it is at going to this position. Now it goes to this position. So it can be seen, and it is just according to how the human machine interface is designed. Okay. I hope this.
Yes, sir. Clear, sir. Thank you.
Okay. Are there any more questions? Okay. So coming to our case study, that is the interfacing of 300 plus robots possible? Now, what do you think? Is it possible or not? Or you must be thinking that Yes, please.
Possible, sir. Possible, sir. But how can we arrange 300 robots in a series? That's my question, sir.
Okay, so how do you think that this can be possible? Because all of these previous slides that I was showing you, these are somewhat related to this. So how do you think that this can be possible? Or you must be thinking that 300 robots is too much. It must be of 100 robots. So what do you think how this can be achieved?
Actually, I joined in the middle of the session, sir. I missed due to work, and I think in electrical we have learned the basic concept called series connection and parallel connection. With that, I see it can be making possible by 300 plus robots, sir. Something like that.
Okay, any more inputs?
So what we can do is we can put some specific number of 50 robots in one slot and create 6 slots, and then we can arrange all those by we can control all those by a server, main server.
Yes, you are actually right. Okay, any more inputs? I'll then proceed.
We can have a matrix kind of approach to interconnect the robots.
Okay, define more of how you are thinking of matrix approach.
Like for communication between the robots and control of the robots.
Matrix, then we had 50 different slots. Okay. Now more inputs, I need more inputs. Okay, so first was matrix, then we had 50 slots. Okay,
then
so
another 60 cross 50.
No, this is you're telling me about the matrix thing, right?
Yeah.
No, so how are you planning on connecting those 50 across 60?
It's same as a 50 across 6, I think.
See, we talked about one thing, Profibus, right? I told that 126 devices can be connected on it, right? So let's say that there's a controller for a robot. Okay, so one controller can have 4 robots connected to it. Okay, so this controller can drive 4 robots at a time. So how many controllers do you think that we'll be needing?
75.
Okay, 70. So first thing we have figured out key controller, we need 75. Okay, now the next thing, that how these 75 controllers are going to be connected. So how many Profibus are we going to need?
One, sir.
Can you hear me? How many Profibus do you think that we are going to?
One, sir.
Good, because that's simple, that we can connect 126 devices, so we can easily connect 75 devices to it. So which are 75 controllers. Simple. Okay. Then this Profibus is just a it is just a mode of transferring those, connecting those robots together. Now this Profibus has to be connected to some kind of device, so that these robots can be controlled from a single place, single room. So what is going to be that device? We studied 3 types of devices just now: PLC, SCADA, and DCS. So what is going to be that device? Is it going to be PLC? Is it going to be SCADA?
SCADA.
Okay, why SCADA?
Because it gives the human interface and it describes about the production cycle and rates, sir.
Then HMI also gives you a human machine interface, and DCS also gives you a human machine interface. Then why SCADA?
I think
supervisory control.
Yes, sir. Yes, sir. Supervisory control.
Okay, supervisory control. Okay, so do you think that you can control all of the data, all of the working from it? Because I told you that that is supervisory control and data acquisition. And we studied that DCS is for complex problems. So what is it going to be? DCS, SCADA, PLC? Okay, I need inputs. Come on, guys, think.
SCADA.
Okay, then we have. Okay, we'll be doing this SCADA, PLC, DCS. So we have 2 people for SCADA, 0 for PLC, 0 for DCS. Any more inputs? Okay, so we are not going to use SCADA for it. We are not going to use PLC for it. We are going to use DCS. Now, why DCS? Think that why are we going to use DCS for this?
Economics, sir.
Sorry?
Economically. I mean, price, cost.
See, cost is not just a single factor, but there are more to it. First, it is the DCS. Just think of it. Okay, I think that SCADA, PLC, DCS is not clear to you. So SCADA, SCADA is just to for data acquisition. So let's say that I am a manager of the company, and there is a fault occurring. There's a HMI interface, and these are some kind of graphics that are designed on the computer, and I can see it on my screen. Okay, so SCADA is what SCADA is going to tell me. It is going to tell me the faults that are occurring. It is going to generate the data, the production and these things, and it is going to bring it to me in a single place. So SCADA is just doing that. PLC is the programmable logic controller. So it is used to program the whole of the, how this basic, actuation is going to be done, how the input is going to be, brought back to us, and how these things. DCS, on the other hand, is kind of a combination of the PLC or SCADA, as you can say. Okay, so you can, let's say there's a teach pendant, as I told you, in the robot. Okay, so teach pendant can be brought to a single room using DCS. Okay, so let's say I have a HMI, and then on the base, I have some kinds of buttons. Okay, so this you can consider this as SCADA. This you can consider this as teach pendant and all. So I can control these robots from these things, and I can see that how this robot is functioning and how this robot is moving from this thing. So that is why we are going to use DCS in this place, because it is used for complex programming, right? DCS is a physical thing. SCADA is a digital thing, and PLC is a combination of both digital as well as physical, because PLC, this is the PLC. This is, it has IOs. It has to be connected for inputs and outputs, and software has to be designed on a computer. Okay, so that is digital. Are you understanding that? What am I, telling? Is it clear to you all?
Yeah. Yeah.
So can we, 300 is just the starting. Can we connect 1,000 robots?
Yes, sir.
Actually, yes. So for 1,000 robots, so let's say that for 1,000 robots, we are going to need 250 controllers. So for 250 controllers, we are going to use 2 Profibus. Then for Profibus, and let's say that this DCS system, it becomes much bigger and bigger, because with more added robots, it is going to be increasing, right? So we'll be needing some more bigger amount of room. Then we'll be distributing those in the whole environment, because 1,000 robots can be is imaginary, but it is not impossible, because we can divide this into substations, and those substations can control some different kind of robotic cells. And let's say that 50 robots can be controlled from this station, then 50 from this station. So that is how the distribution works. So although this 300 plus robots, these are not in all of these industries. This is not even in the JBM. It is in the Tesla, we can say. But mainly DCS is used for bigger things like the power plants and these things. Then SCADA is also used for these power plants or some kinds of smaller smaller applications. PLC can be seen in almost every industry. Okay, so it is used in from the basic application to the large extent of application. So that is how the interfacing of this works. I hope all of you are clear on this thing.
Clear, sir.
Okay. Is there any query, or should I proceed further? Okay. So we are at the end of the slide now, and so let's see what we have studied so far. So I told you about the JBM group, that how this JBM group is active in the automation industry, and how it is succeeding in the manufacturing business, and how it has set up 40 plus plants around the world. Then we introduced you to the concept of the automation, and we studied about the autonomous versus automatic, and we saw some examples for it. We studied about the concept of the automation in manufacturing, and what are the components that are needed for the automations, which are sensors, and then there's PLCs, SCADAs, and then there were actuators, solenoid valves, and all. Then we studied about the different modules for automating in industries, and we studied we had a case study for 300 plus robots. So thank you for the session, and I hope you learned something from this, and I'm open to many more questions if there's any doubt. You can ask anything about the your engineering background or robotics background, or some from the from the current session?
Sir, being from a mechanical engineering background, from today I have understood something about robots, sir. But somewhere I want to know about IoT, sir, Internet of Things. I don't know what that word means. Can you explain some points, sir? At least 2 minutes or 3 minutes.
So you want to understand about the IoT, and you're from mechanical background.
Yes, sir.
See, I'll tell you one thing that you guys must have heard of mechatronics. So mechatronics is a combination of many fields. So it is a combination of mechanical, it is combination of electrical, computers, and all. It is a multidisciplinary field, right? So studying all this, you need to have some basic concepts. So being from mechanical, you covered 33% of the part, right? So you might need to understand few of the electricals and the computers part, and that can be studied. So being from this background only, I am from robotics. My background is from robotics, so I had a multidisciplinary field. So the thing is that you need to first define yourself. Are you really do you really want to go into IoT, or you are just going after the crowd that everybody is opting for IoT and I should also opt for this? Or do I really need to do that? Because that is what is going to define you. So now let's say that robotics used to amuse me. So that is why I took robotics field. But I could have chosen automotive, or I could have chosen mechanical, but those were not the fields that I was ready for. The robots were the things that used to amuse me. But if you're going in that field because I will get good growth there, and I will get good amount of salary there, that is not the thing. If you are good enough in mechanical also, you will get good salary. I've seen people passing out from tier 3, tier 4 colleges, and getting a salary of 24-25 lakhs per annum. So you need to be good in that. Anything that you do, if you're doing mechanical, you should be good in that. But if you really want to change your fields or anything, so we as Elite Techno Group is helping people with that. So I've provided a feedback form in the comment section, so you can fill that, and our marketing team can reach out to you and can help you with this, right? So are there any more questions? Okay, so that was all for today, and I hope you learned a great amount of things. So we'll be conducting more boot camps in the further sessions, and we'll be doing some hands-on. So as we studied the PLC, programmable logic controller, today, so I'll be giving you many tasks like this, and we'll be doing some more interactive session like this. Okay, so I wish you all the best of luck, and keep learning and keep exploring. Bye-bye, guys.
Thank you, sir.